All right, in 9.2, we're going to be comparing two populations, specifically testing the claim about a difference between two proportions. So in 9.1, we did confidence intervals. 9.2, we're going to do significance tests. So in a test for comparing two proportions, the null hypothesis has the general form, where the null is P1 minus P2 equals some hypothesized value. Now, in this class, we're going to restrict ourselves to situations in which the hypothesis difference is 0, meaning there is no difference between the two proportions. The null hypothesis says there's no difference between the two parameters, so there it is. So how do you check the conditions for performing a significance test for P1 minus P2? Still, it's random and large counts, so let's talk about this. Random, the data has to come from separate random samples from the two populations or from two groups in a randomized experiment. So you have to mention the separate random samples, two random samples from the two populations. You have to mention that when you clarify your condition. On the large counts, it's still large counts test, but you have to do it for each group. So look, I have N1 times P1, N times 1 minus P1, and then the other group, N2 times P hat 2, N2 times 1 minus P hat 2. So you have to do it twice. You just got to do large counts twice. It's still, they have to be greater than or equal to 10. Nothing's changed. So if the conditions are met, you can proceed with the calculations. To do a hypothesis test where the null of the difference is 0, we standardize P1, P hat 1 minus P hat 2 to get a Z statistic. And this is the formula. Now, I don't really care if you get the formula down on this. I just want you to know what P hat 1 is, P hat 2, N1, N2. All right, so you're going to use your calculator to do most of the work on this, okay? So I want you to see on the stat test screen, you're going to be using option number 6 right here, okay? Two proportion Z test, there it is. And when you click on that, this is what comes up. X1 over N1. X2 over N2, and then you pick the correct inequality, not equal to, less than, or greater than. All right, so you need to be real careful about which one is X1, which one is X2, and I'll show you an example when you write the problem as to how you know which one is what. Okay, so let's try an example. Okay, so let's look at example 1. Many new products introduced into the market are targeted toward children. The choice behavior of children with regard to new products is of particular interest to the companies that design marketing strategies for these products. As a part of one study, randomly selected children in the different age groups were compared on their ability to sort new products into the correct product category, milk or juice. They had to decide is it milk or juice. Here's some of the data. Okay, so we look at the table, and we can see that they did a set of 4 and 5-year-olds. 10 out of the 50 got it right. Out of the set of the 6 to 7-year-olds, 28 out of the 53 could sort between milk and juice correctly. So the researchers want to know if a greater proportion of 6 and 7-year-olds than 4 and 5-year-olds can sort correctly. That's what they think, and that's what we're looking for evidence of. All right, so state the appropriate hypothesis for performing a significance test, and be sure to define the parameters. Like always, we have to define our parameters clearly. All right, so the good news is when you're doing a difference of proportions, your null is always going to look the same. Okay? It's going to be P1 minus P2 equals 0. The alternative is still going to be P1 minus P2, and it still has a 0. You just have to decide, is it a greater than or less than? Now your clue right here is greater proportion, right? It says greater proportion, so we're going to make it greater than. Now, here's where it gets a little bit tricky. You have to decide which one is P1 and which one is P2. Well, what do the researchers think? They think that the 6 and 7-year-olds will be greater than the 4 and 5-year-olds, right? So I have to clearly define P1 is the true proportion of 6 to 7-year-olds who sort correctly. P2 is the true proportion of 4 and 5-year-olds who sort correctly. Okay? So that's the first step. All right, so check that the conditions for performing the test are met. All right, still two conditions, random and normal. So when I do random, I just have to make sure that both samples are random, okay? So let's see, the 4 and 5-year-olds, n was equal to, what, 50? And it's a simple random sample, it tells us that. 6 and 7-year-olds, n was 53, and it's a simple random sample also, they told us that. Now for normal, okay, we're going to do the large counts test. But to do that, you got to know what p hat 1 is, and you also need to know what p hat 2 is. So remember, p1 is this, p2 is the 4 and 5-year-olds. So let's figure out p1. 28 out of 53, that comes out to 0.53. And then p2 is the 4 and 5-year-olds. That's 10 out of 50. That comes out to 0.20. All right, so now we have what we need to do the large counts test twice. So let's do p1 first, okay, the 6 and 7-year-olds. So I'll do 53 times 0.53 gives me 28, which is greater than or equal to 10. And then I do 53 times 1 minus 0.53. That gives me 25, and that's greater than or equal to 10. Okay, then I do the other sample. Okay, that's 50 times 0.20. That gives me 10, greater than or equal to 10. And then 50 times 1 minus 0.20, that gives me 40, which is greater than or equal to 10. So I've shown normality because both sets pass the large counts test. All right, step 3. Here it is. Calculate the test statistic and corresponding p-value. Now, I don't want you to mess with the formula on these. They're a little more complicated, so I'm going to mess with it. But I do want you to use your calculators and clearly identify. In the calculator, it's going to ask you for x1 and n1, x2 and n2. You've got to be really careful. Which one do we put as the first one? Okay, that goes with p1. x2 and 2 go with p2. We said p1 was 6 and 7-year-olds based on the research, right? So x1 is 28, n1 is 53, x2 is 10, n2 is 50. And remember our alternative hypothesis was a greater than symbol? So we're going to use all that information and plug it into our stat test. So let's go to stat test. Remember, you got to do two proportion z-tests, number 6 right here. So there's 28 out of 53, 10 out of 50, and I pick the greater than. If I hit calculate, look at that. It's going to give me a z-score of 3.45. So I want you to put on there z equals 3.45. And you're still going to draw for me the curve. Where is that? Well, positive 3.45 is over here, and it's greater than, so I shade to the right. Now the p-value. Here it is on the screen. Look at it carefully. Look, it's 2.79 times 10 to the negative 4th. Again, you've got to be really careful. I don't want you to put your answer like this. That is no good. When it's like that, that is 0.000279. So what you need to tell me is the p-value is approximately 0. Okay? Now, we're not drawing the conclusion yet, but you can see what would happen. Because z is less than our alpha, which is probably 0.05, we would reject the null. Okay? But today I just kind of want to get your feet wet with this and get you used to the process. All right? So that's how you handle it with the two proportion significance test.